In this video we'll look at what happens when we have three equations with three unknowns. With the first example of these three equations here. Now remember that an equation with x, y and z can be expressed as a plane in three-dimensional space, and if we were to graph those we end up with this image here. So we can see the three planes there. Two appear to be parallel and one cuts across both, but there is no common point of intersection amongst the three planes. So for that system of equations there is no solution. Now let's see what happens if we were to use our graphics calculator. We'll go to equation, so into here we've got simultaneous equations. So F1, we have three unknowns, hit F2 and now place the coefficients. So we have the coefficients in. If we hit solve or F1 we'll see there's an error, can't be done, no solution. Now let's consider a new set of functions, and we'll put those into the graphing program. And we end up with these planes here, and we can see if we move it around, these three planes are parallel to each other. And notice the equations of the planes, the coefficients of x, y and z are all the same. The constant is varied, and therefore these planes are parallel. Which once again means no solution, which we can see graphically on the calculator. Let's have a look. And there they are, the values are placed in, so hit solve, and once again, error. Now a third and final example. We have our three equations here, and if we graph those three, we end up with this situation here. And if we rotate the object, you can see the three planes, while pairs of them intersect, there's no point of intersection amongst all three. There's no common point of intersection amongst all three planes. So we don't need parallel planes, be it 3 or be it 2. We can have oblique planes that still don't have a common point of intersection amongst the three of them.